Hello friends, welcome back. Hearty welcome to you. Let's look at this problem related to complex numbers. We have been given that modulus of z1 minus 2z2 divided by 2 minus z1 into conjugate of z2, the whole modulus is equal to 1, or this whole thing is unimodular. And we also have been given that z2 is not modulus of z2 is not equal to 1. Then we have to find out what we can say about z1. That point, is it a part of a straight line or is it a point on a circle? So we have to get the equation for z1. Okay, so what we will do for this particular problem, we'll try to apply some of properties of complex numbers. First we'll understand those properties, then we will go ahead and try to solve this problem. The property is very simple. If we have a complex number z, we multiply that with its conjugate, then it is nothing but equal to modulus of z whole square. This is the property which we are going to use now, because since we have modulus now, we square it up, then we write in the terms of from right hand side, we write it as left hand side, then we try to solve it and try to find out. So z1. Okay, so the first thing we have to understand is how this is correct. So let us say z is equal to x plus iy. Then what is z into conjugate of z, x plus iy, into conjugate is nothing but x minus iy, which is nothing but equal to, let's multiply this. This is the x square minus ixy plus ixy minus I square y square. Now I know that ixy cancels. I am left out with x square minus I square y square. We know I square is minus 1. The whole foundation of complex numbers is I square equal to minus 1. So it's x square plus y square. Now what is x square plus y square? Square root of x square plus y square whole square. But what is root of x square plus y square? It is nothing but modulus of z. So z into complement of z equal to modulus of z whole square. This is the property which we will utilize to solve this problem easily. So let's go ahead now. So we will take whatever is given to us and we'll try to square it on both sides. So can I say that modulus of z1 minus 2 into z2 is equal to, if I take it to right hand side, it will be 2 minus z1 into z2. So what I did is just simply taken the denominator to left hand side, and that is z1 minus 2z2 modulus is equal to 2 minus z1 z2. Now what we will do, we'll square it on both sides, because we want to apply the formula that mod z whole square is equal to z into complement of z, conjugate of z it is. That's what we want to leverage. Okay, so let's go ahead and write the next step. Then next step will be, we can write it now as product. So we will see what it is. We'll first write down z1 minus 2 into z2, that I have to multiply with its conjugate now, that is conjugate is z1 dash minus 2 z2 dash. So whenever we have a complex number which itself is combination of complex numbers, you want to find out the conjugate of that. Wherever there is a complex number as part of it, you just put conjugate of it. So z1 conjugate will be z1 dash, z2 conjugate will be z2 dash. Similarly here it will be 2 minus z1 multiplied with z2 conjugate. Now its whole conjugate will be 2 minus z1 conjugate, and z2 conjugate, that is nothing but z2. Hope I haven't confused you. Now let's multiply this. Let's multiply and see what happens now. We'll have z1 into z1 conjugate minus 2 z1 conjugate into z2 minus 2z1 into z2 conjugate plus 4 into z2 into z2 conjugate is equal to, coming here we have 2 2's are 4 minus 2z1 conjugate z2 minus 2z1 z2 conjugate. We're just doing the multiplication, nothing else. Then after that we have plus z1 into z1 conjugate into z2 into z2 conjugate. So now again we'll go back and apply the formula whatever we know. The formula is, if I have z into z conjugate, then it is nothing but equal to mod z whole square. So can I write it now as mod z1 whole square? I can cancel these two. I have plus 4 into modulus of z2 whole square is equal to 4 plus z1 into z1 conjugate is mod of z1 whole square. Similarly, the next one is mod of z2 whole square. Now this is a quadratic equation. How we will simplify this now is, let us say that z1 is, we'll say for some time that z1 equal to x and z2 equal to y, or shall I say mod of z1 is x and mod of z2 equal to y. What will happen now? This, let us look at this, x square plus 4y square is equal to 4 plus x square y square. Or can we get everything to one side and write it as x square y square minus 4y square minus x square plus 4 is equal to 0. Can we write it as now y square into x square minus 4 minus of x square minus 4 equal to 0, which is equal to y square minus 1 into x square minus 4 equal to 0. This is only for our understanding, we have just written it. Now what we will try to do, we'll try to convert this again back into our whatever we know mod z. So it will be nothing but mod z2 whole square minus 1 multiply with mod z1 whole square minus 4, which is equal to 0. But we know that mod z2 is not equal to 1. If mod z2 is not equal to 1, obviously we know that first term will not be equal to 1. That means the second term is equal to 1. So can I write down, that's nothing but equal to mod z1 whole square minus 4 equal to 0, or mod z1 whole square equal to 4. Let us say if z1 is x1 plus iy1, then it is nothing but x1 square plus y1 square equal to 4. Now what is the meaning of x1 square plus y1 square equal to 4? The meaning of x1 square plus y1 square equal to 4 is x1 comma y1 is a point on curve x square plus y square equal to 4, which is nothing but circle now. Circle x square plus y square equal to 4, which is having center at 0 comma 0 and radius is equal to 2 units. So what we can say about z1? We know that z1 is a point on circle which is having radius of 2 units. So that's a solution for this particular problem. Let me just recap this. We have been given that mod of z1 minus 2z2 divided by 2 minus z1 into z2 conjugate, whole mod of that is equal to 1, and we have been told that mod of z2 is not equal to 1. Then we have to find out what is the nature of z1. What is that particular point? Is it a point on a straight line or a circle or ellipse or a hyperbola? We have to find it out. So the property we have used to solve this problem, our approach was that mod of z whole square equal to z into conjugate of z, because since we have been given mod z, with this suppose you take z1 equal to x1 plus iy1, z2 equal to x2 plus iy2, it will be very complicated. So what we did is we applied this particular property that mod z whole square equal to z into z conjugate. Now whatever is given, we have squared it on both sides, numerator denominator. We got an quadratic equation in terms of mod z1 and mod z2. We simplified that. We got mod of z1 square minus 4 into mod of z2 square minus 1. But we know mod of z2 square minus 1 is not equal to 0. The first part is not equal to 0. Then obviously second part should be equal to 0. If I take z1 equal to x1 plus iy1, then z1 square is nothing but x1 square plus y1 square, which is equal to 4. That means it's x1 comma y1 is a point on circle x square plus y square equal to 4, which is having center at 0 comma 0 and radius equal to 2 units. So if it's a multiple choice question, you will look for an option where it says that is a point on circle with radius of 2 units. So that's the solution. So I'll catch you once again with another interesting example. Till then, keep smiling and sharing. Bye for now.